All right, let's go ahead and expand on this concept of mole ratios and add grams into the mix here. Before, we learned about how we can go from moles of A to moles of B. So we can go from moles of one substance to moles of another. For example, let's say we had 4 moles of hydrogen gas. How many moles of oxygen gas would we need to react with 4 moles of hydrogen gas? Well, we go from moles of hydrogen gas to moles of oxygen gas, and we use these coefficients here because we know that 2 moles of this will react with 1 mole of that. And the concept that we really learned was understanding the idea that moles of or that these coefficients can represent moles. So this 2 can mean 2 moles will react with 1 mole to produce 2 moles. All right, so now what we're going to do is we're going to expand on that and add grams into the mix here. And so it's going to be there's actually not really going to be anything new that we're learning because we've learned how to go from grams to moles. And the idea is that if you're given grams, all you need to do is go from grams to moles. And then once you are at moles, you can go from moles of A to moles of B. You can go from moles of one substance to moles of another. And so just a quick reminder, the molar mass is the mass in grams of 1 mole of a substance. And the molar mass is the conversion factor that relates mass of a substance to moles. And so we use molar mass to convert between grams and moles. And so again, this is nothing new. For example, if we had, let's say, 88 grams of carbon dioxide, we can go from grams of carbon dioxide to moles of carbon dioxide because we know that carbon has a molar mass of 12.01, oxygen has a molar mass of 15.999, but we multiply this by 2. And then when we add this all together, we end up getting around 44. So we get around a molar mass of 44. So this here is the molar mass, and it allows us to convert from grams to moles. And this would end up being 2 moles. So again, this is not anything new. So now what we're going to do is we're going to take this concept and tie it together with our mole-to-mole concept. So this first part is what is the molar mass for each reactant and product? Well, we have H2, right? And hydrogen has a atomic weight of 1.008, but we multiply it by 2. And so the molar mass of this is going to be 0.16. Then we have oxygen gas, which is each oxygen is 15.999. But again, there's 2 oxygens, so we multiply it by 2, and this ends up being 31.998. And then we have H2O. Okay, well, hydrogen again is 1.008. Oxygen is 15.999. But we multiply this by 2 because there's 2 hydrogens. And then when you add this together, you get 18.015. And so this is the molar mass of that. This is the molar mass of that. And this is the molar mass of the water. And so again, this is not anything new. But what we're going to do is we're going to bring these 2 concepts together to where before, in the last ed puzzle, we talked about going from moles of A to moles of B. So we were only going between these 2. But what we're going to do now is we're going to start either here or here. So we'll start with either grams or moles, and we're going to go to either moles or grams. So we're going to finish with one of these 2. Now, this mole map here is in your booklet. In fact, if you look on the second page, you'll see this mole map here, but it's in greater, there's more things added to it that we haven't learned yet, but we will get to those things in the future. But you'll see that the one in your booklet, it has mass, mole, mass. this actual diagram is in your booklet as well on the concept page in your booklet. So it's after, if you go past these notes a little bit, where the reviews are for this particular unit, you'll find this particular mole map here. So let's go ahead and do this practice problem. So I'm going to break it down. I'm going to go really slow. We have a total of 3 practice problems that we're doing, and these practice problems really sum up everything that we need to know. So this particular chemical reaction is saying, this problem is saying that we have 852 grams of NH3. And so we're starting with grams, so we're given grams, so we're actually starting right here. Okay, so we're starting with grams of A. In this situation, A is this, okay? So A is the NH3. So again, we're starting here, and we're starting with grams of NH3, which happens to be this right here. And what it's asking for is, this first problem is asking for how many moles of NO are formed. Notice how this here is a different substance. So it's asking for moles of a different substance. Something that I really want to highlight here is all of this here is substance A. This all is the same substance. So if we have grams of NH3, we can go to moles of NH3, we can go to molecules of NH3. And so these are all the same substance. This here is a different substance, and I'm going to actually go like this. This here is a different substance, and so this is B, and then this is the bridge that connects the two, all right? So in this first problem here, we are given grams of A, and it's asking for moles of a different substance. So it's asking for us to go here. So we're starting here and going here. The question is, can we go directly between grams of A to moles of B? The answer is no. We have to go from grams of A to moles of A. And then once we know the moles of A, we can then go one more step to moles of B. And so if you look at this flow chart here, this flow chart is telling us that this is going to be a 1-2 step problem. So we need to go 1, 2. So it's going to be a 2 fraction problem. So step 1 is to write what's given to you. So we are given 852 grams of NH3. And what's going to be extremely important, is that you're writing the proper unit. So you're writing grams and you're writing NH3. You need to include this because we're now dealing with different substances here. Then what we're going to do is we're going to multiply by some fraction, and like always, whatever units you start with will always go on the bottom. This first part here, there's nothing new to this. This should be very familiar. We've done this quite a bit over the semester, over the school year. So this setup is going to be the same no matter what. No matter where you're starting, no matter where you're going. You're going to write what's given to you. This is what's given, and you're going to multiply by some fraction, and then whatever units you're starting with go on the bottom. Now, if we look at our flow chart here, so here is grams of A. And in this situation, I'm going to go ahead, just to reiterate, A is going to be NH3. So NH3 is substance A. And then substance B, it's asking for NO. Okay, so NO is substance B. So first we're going to go from grams of A to moles of A. So that's moles of NH3. These cancel. We're left with moles of NH3. But we don't want moles of NH3. We want to go to moles of NO, because again, it's asking for moles of NO. So now we are here, and now we're going to go from moles of A to moles of B. So we're going from moles of NH3 to moles of NO. And again, how do we cancel this? We cancel that by putting it on the bottom here. Again, this is really nothing new in terms of canceling units. It's just we're using a different flow chart. And then we're going to go from moles of A to moles of B, which is going to be moles of NO. And so what I'm actually going to do is I'm going to change the color of this to signify that we have a different substance now. So now we've converted it to a different substance. So what we do now is we've got our unit set up, and it's really important to get your unit set up, because if you can set up your units properly and then fill in the numbers, you should be good. Now, before I've always been like, what goes in front of moles? What always goes in front of moles? Well, the answer is 1. A 1 will always go in front of moles except when it's a mole-to-mole conversion. If it is mole over mole, notice how it's mole over mole, you do not automatically put a 1. Instead, you use the coefficients from the balanced chemical equation. So what's the coefficient for NH3? 4. What's the coefficient for NO? 4. So they happen to be the same. They won't always be. But again, when it's mole over mole, this is where you don't put a 1, but rather you put the coefficients. Now, what do we use when we go between grams and moles? And if you look here, what we use is the molar mass from the periodic table. So again, when we go from grams to moles, we use the molar mass. And what are we using the molar mass of? Is it the molar mass of NH3 or is it the molar mass of NO? Well, notice how this is substance A, so we're still in the region of substance A there, so we're using the molar mass of substance A. The other way we know is because we wrote grams of NH3 there, so we will do the molar mass of NH3, and so nitrogen is 14.007, hydrogen is 1.008, but we multiplied this by 3, and then we add it all together, and we end up getting 17.031 when you do that. So the molar mass here is 17.031. Now all you do is you type this in your calculator. And when you do that, you end up getting 50.026 moles of NO, because we're left with moles of NO. Except that's not quite right, because we need to count sig figs. So we need to consider sig figs. I know it's been a long time since we've really done that, but it's really easy. The sig figs you start with, we're starting with 3 sig figs, need to be the sig figs you end with. So there's the answer with correct sig figs. 50.0 moles of NO. All right, let's go ahead and do this next problem here. This next problem, so just a quick reminder, this was 50.0 moles of NO. So that was number 1. Number 2, it's now asking for moles of H2O. Okay, so again, we're starting with 852 grams of NH3. And just a quick reminder, this is the setup for problem 1. So I want us to keep this in mind. This is the setup for problem 1. We're going to moles of NO. All right, so let's go ahead and do this next one. This next one is asking for moles of H2O now. Well, again, we're starting with 852 grams of NH3. We then multiply by some fraction. The units we start with go on the bottom. Notice how this looks exactly like the setup above. So this is number 1. Again, this is number 1. Now we're doing number 2. Again, we're starting with this. So we're starting with grams of A, and again, this is NH3. This time, though, we're going to H2O. So we're going from grams of A to moles of A first. So we're going to moles of A. Again, this actually looks exact. These two parts look exactly the same. Okay, well, this here cancels. We're left with moles of NH3, and so we put moles of NH3 on the bottom. And again, it looks the same. But this is where it's different, because now we're at grams of our moles of A. We need to go to moles of B, and this is where we have a different substance. So this is now moles of H2O. This is all set up exactly the same except for this part right here. This is the only part that's different between the two. So I want you to just keep that in mind, that there's a lot of there's a pattern involved in all of this. So anyways, what always goes in front of moles? A 1. We already calculated the molar mass of this, which is 17.031. A 1 always goes in front of moles except for when it's mole to mole. We use the coefficient from the balanced chemical equation. The coefficient for NH3 is 4. The coefficient for H2O is 6. Notice that this is going to be the difference. And it makes a lot of sense too, because 4 moles of this produce 4 moles of that. But 4 moles of this produce 6 moles of water. And so you can see that we're going to have 50% more essentially. So when you type this in your calculator, you do end up getting 75.0 moles of H2O. This here is the part of the conversion that we learned last class period. We're adding this part to it, which we've already learned this year. And so there's really nothing new that we're learning. We're bringing two concepts together. So let's go ahead and go on to the next problem here. This here is going to be a different ending point. So this one, you'll see we're going to start with grams of A and go to grams of B. And so if you take a look, the question is, how many grams of tin fluoride are produced when 30 grams of HF are reacted? So what we're starting with is, we're starting with grams of HF. So we're starting with grams of A. And again, we're always going to start over here somewhere. So it's grams of A. And so A in this situation is HF. We're then going to, what it's asking for grams of B. So it says how many grams of this other substance, and B in this situation is the tin fluoride. It's the tin 2 fluoride. So we're starting here and going here. So how many fractions will we end up having here? Well, we've got 1, 2, 3 fractions. So according to this flow chart, let's think about this. We're going to start with grams of A. We're going to go to moles of A. That's this part right here. We're then going to convert moles of A to moles of B. And then we're going to convert moles of B to grams of B. And so this is our flow chart. So we're starting here and ending there. All right. So let's get started. Step 1 is write what's given to you. We are given 30.0 grams of HF. Because again, we're starting with grams of A. We multiply by some fraction. The units you start with go on the bottom. So we're starting with grams of HF, and so we put grams of HF on the bottom to cancel out the units. Again, it's all about canceling out the units. Then what we're going to do is go from grams of A to moles of A. So that's going to be grams of HF to moles of HF. And if we were to stop here, we would successfully convert to moles of HF, but we don't want to do that. We want to go all the way to grams of B. So what we need to do is go from moles of A to moles of B. And again, because we want to cancel this out, it ends up going on the bottom. Now this is where we now are going from moles of A to moles of B. So now we have a new substance here. But again, we don't just want moles of B. It's actually asking for the grams of B. So it's asking how many grams are produced. So again, we're starting here, and the question is how many grams are produced in this chemical reaction. So we put the moles of SnF2 on the bottom. And we're going to go to grams of SnF2 on the top. So we're going from moles to grams. And so notice how I've color-coded it to where all the purple is one substance. The blue is a different substance. Notice the symmetry there. Now we go ahead and fill in our numbers. And what I really want to highlight is if you're able to cancel out your units properly, you should be able to fill in all the numbers with ease. What always goes in front of moles? A1. A1 always goes in front of moles. Except when you go mole to mole. When you go from mole to mole, you use the coefficient in the balanced chemical equation. So what is the coefficient for HF? It's 2. What's the coefficient for SnF2? Well, there's nothing there, so it's a 1. Then, when we go from grams to moles, we use the molar mass from the periodic table. So when we go from grams to moles, we use the molar mass from the periodic table. The molar mass for HF is going to be 20.006 And the molar mass for SnF2 is going to be the 156.707. And that's our setup here. So I want you to really look at the setup real quick and make sure that you're able to understand where, like how the units are set up, how we canceled out the units. Really, this flow chart here is going to be really crucial. It is in your booklet. It's in several different parts of your booklet, and I'll show you in class. But make sure that you're able to understand where we got these numbers. And when are we using the molar mass? We use it when we go between grams and moles. And then, so all we do is type this in our calculator. And when you do that, you will end up getting, with sig figs, 117 grams of SnF2. This guy's got some bushy eyebrows there. There we go. All right, so that's all there is to it. And it's really, once you kind of make this connection that we're taking this new concept here and just adding an old concept to it, it's really not too bad. Setting up your units are the very crucial part. If you need further help on this, I am going to ask you to come to tutorials, because everything that we just did right here is foundational for all of chemistry. Any chemistry class you ever take, what we're going to be doing for the rest of the semester, all of it, this is foundational. And I promise you that it is something that is attainable, that you can pick up, that it's something that you can get to the point where it's pretty straightforward. So it's just with practice. So if you have any questions, if you want to go through some practice problems, reach out to me for tutorials, and we'll schedule a time together. I'll see you in class. Have a great day.